Join me in welcoming Jackie Lasky and Sarah Yoder.
Do we each get one? Hi, so I'm Jackie Lasky. Sarah Yoder. So we're two cybersecurity engineers here at MITRE. And today we're just going to share with you some of our methodology behind TRAM, which is our project that we've been working on to create an easier way to map threat reports to attack. So we'll start with how does information get into the attack site? This usually starts with finding open source threat reporting, so looking at common vendors like FireEye, SecureList, CyberReason, those kind of things, and basically choosing reports based on the content that's in them. So we're always looking for new reports on new APT groups, malware, things like that. And then when we have a report, we'll finally go through and we'll start from beginning to end, reading the report, and looking for different attack techniques that are in there. And some of you that may have been in the CTI workshop yesterday have learned that this is a really manual process and it takes a long time. We usually start when we're going through a report with looking for the tactics. We'll kind of highlight along the way any verbs or any tactics that we may think an adversary is trying to do. And then when we're done, we'll kind of repeat this process and look for all the techniques in the report. So it takes a really long time to be able to cross-reference the tactics, the sentences, and going and looking for the techniques that they map to. Yeah, so all the data that's added into our attack site is done manually, which means it's hard to keep it up to date. We usually often have a huge backlog of reports that are unanalyzed, and we have to prioritize some over others. So we also have things like human error. So two analysts may look at a report and have two different interpretations of the same text. This also introduces things like availability bias. So basically, what that means is that you're more likely to think of the attack techniques that you're already familiar with or that you already know of, which can cause you to overlook some of the less common techniques that are out there. So that's also a challenge that we have. And then also training new team members is really hard to do too. Attack is a huge site and it's continuously growing every day. So it's a lot to take in when you first start here. So that's where our solution called the Threat Report Attack Mapper comes in. We call it TRAM for short. And basically, obviously, as Katie said, this project grew out of a need to be able to automate some of the stuff that we do here. So we're just going to give a quick little overview of sort of the details to our technical approach as we started this project. We don't have a lot of time to get into too big of the details, but you can always find us after. So the first step in our process was to get data in. And how we did this is we used a STIX-and-TAXII server. And basically, we just grabbed down all the example data from each techniques page, and we're going to use that for our training data set. So before we could do that, a lot of the text in the world is unstructured raw text, so in some human language. So we had to be able to get it into some language that the computer can understand. So this is where a lot of our data normalization and natural language processing occurs. So doing a lot of things like removing stop words, doing our stemming, lemmatization, things like that. That's all going to occur in this step. And then once we've got the data in a good format, we can start building and training our models. So to do this, we use Python's logistic regression, which is a supervised learning classification method. And essentially what each technique has is they have their own model built for them. So we'll have a positive and a negative class that we build for each technique. So the positive class consists of the examples from the attack site, and then the negative class consists of a variety of things. So maybe like true negatives of sentences that don't relate to any technique at all, or maybe other techniques examples to also differentiate between different techniques. So after we've trained and built our models, we had to collect a good, reliable test data set that we could use. So we did this using our own Feedly CTI RSS feed. They have a Python API where you can just kind of grab a bunch of reports that you want to look at, and we used that to collect sort of the test data set that we used. So once we had our test data, we were able to transform our test data with the models that we built from the previous step. So this is where we can perform a lot of our cross-validation and checking how our models are performing as we go through this process. And then once we have ran our reports, our test reports, through the models, we get sort of a printout that the analysts can look at and decide whether they approve or reject basically the techniques that were found in the model. So they'll have a list of all the techniques that were found in the report, and they can go through and decide whether they like them or not. And then we can also add in ones that are missed as well. And to pull it all together, we have a feedback loop to be able to improve our model as we go through. So we use a database to be able to track the different true positives, false positives, true negatives, things like that, so that we can include it and make the model better each time. And we use a serialized format in Python called a pickle file so that we can reload and rebuild the models whenever new data gets added to the attack site. So this is still, along the way, we had a lot of challenges that we still had to overcome. But the most obvious challenge is extracting meaning from text is still really hard to do. Humans are still needed in this process. We haven't got rid of us yet, but we still are using us. So we still need to be part of that process and improving the feedback loop, improving the models as we go. But the problem almost always comes back to not having enough data to train with. So this can lead to things like imbalanced data sets, so maybe having a really large negative class of training examples, but a really small positive class of examples that are good. So that's one of the challenges we had to face as we went through this. We had some techniques in ATT&CK that don't have any examples at all, or maybe they only have 1 or 2 examples. So for those kind of cases, we had to look at them on a case-by-case basis and sort of build out regular expressions and string matching kind of things to be able to kind of handle those cases that we couldn't build enough models for.
Cool. So now I'm going to go over just how it looks. So because we have a short time slot, a lot of this demo we're just going to skip through. So at this point in the tool, we would assume that the analyst has gone online, found a report that they're interested in, they grabbed the URL and ran it through our tool TRAM. So when they go to analyze that report, this is the view that they would see. And as you can see, if they click on the highlighted sentence, it'll show you a couple of techniques that TRAM found. So in this example, spear phishing link and attachment. Going back to what Jackie said, sometimes the computer still has trouble distinguishing very similar techniques. From here, we can go ahead and reject spear phishing link, since that wasn't what this sentence was talking about, and confirm or accept the spear phishing attachment, since that was correct. And as you can see, it got rid of the spear phishing link from the list and add spear phishing attachment down into the confirmed techniques. So from here, as Jackie mentioned, the models will be updated based on the accept or rejects as an analyst goes through this report. So you would follow this process for the rest of the report, and you can then export it as a PDF. So at the bottom of the PDF, you would get a chart that looks like this that has all of the confirmed techniques from the report that you analyzed. So we hope that this is a useful little snippet that the analyst can use to share with maybe other members on your team, or for us, the use case will probably be feeding this into ATT&CK to get more information into the site. So why does this matter? Other than our use case, which was to automate our jobs, we hope that it's useful for you as well. We know that mapping reports to ATT&CK can be kind of overwhelming. There's a lot of techniques to choose from. And so we hope that this is a good starting place, since there's only a handful of techniques that the analyst needs to review per sentence. As Jackie mentioned, remembering 266 and growing, techniques is hard, and there's many techniques that sometimes I forget about. And so luckily the computer doesn't have that problem, so it can remember them for us. And next, we hope that you can use reporting that's important to you. So whether that's an internal report source, or if you feel like ATT&CK doesn't have enough information on maybe the financial sector or healthcare, whatever your use case may be, we would hope that you can use this to get more data for the techniques that you care about. So some takeaways. Many people have talked about ATT&CK helping to frame behaviors, moving away from IOCs, and we hope that you can use a lot of what other people are discussing today, mainly our 4 main ATT&CK use cases, which are detections, kind of the SOC assessments, and gap analysis. You can track adversaries you care about using cyber threat intelligence, and then potentially emulate those adversaries. We acknowledge that mapping data to ATT&CK is hard, but that's where we hope that TRAM can come in and make that easier. So with that, we have some time for questions. Oh, most importantly, this will be open source and available to the community, hopefully by the end of the year. Yeah, we have microphones come in. Oh, okay.
Hi, ladies. This is fantastic. I'm wondering if you've had any, I guess, experience, or the community's had any experience with overlapping this with like a tip, whether it's MISP or a commercial tool, and integrating those two things.
Yeah, so we're still really early in this process on building this, but I could see as it gets more mature and if the community can help make it even better, that maybe that definitely would be an option
down the road.
to be used.
Just a real quick technical question on your NLP. Was that the only library or learning model that you considered, or were there maybe a couple other candidates?
We were mostly just using the natural language toolkit in Python. It's one that I was already familiar with, and we definitely, both of us kind of have a small background. I have a computer science major, but I don't have a PhD in AI or machine learning, you know, so I just kind of went with what I was familiar with and what she was familiar with, using our backgrounds, and that's kind of how we went from there in the limited time that we had. So. Any others?
Yeah.
Sorry, I wasn't sure if it was my turn. I got my PhD from YouTube on machine learning, so we're in good company. When you do the release in open source, Jupyter Notebook perhaps?
Our old code used to be on Jupyter Notebook, but we have it in a web app now, so no more Jupyter Notebooks, unless people want them. But
All
I feel like that's
code.
my old code.
Thank you. It was a great effort. You did a great job on this. I think that the community can really run with this, so I appreciate it.
Awesome.
Sarah and
Any
Jackie.
others?
Got one in the
We have
front.
one in the front here.
Getting your exercise today, huh?
Great.
So if I'm understanding it right, basically it's going to be a web app that's going to be hosted by you guys, correct?
No, so
Or-
it's actually all run locally. So,
Oh, locally.
Yep.
Okay. Because the next place I was going was how you were going to deconflict potentially if two people submit the same report and then train it, but.
Yep, so right now it's run locally on the user system. We have looked into having it in more of a centralized location so that multiple analysts would be able to use it at the same time to kind of curb your thought of deconfliction, where we have some features that are in the works to kind of tag reports that would say, like, Sarah's working on this one, Jackie's working on this other, so that hopefully the same analyst isn't working on the same report.
Would you have the option to send the reports back to you guys to then update the attack matrix?
Yeah, through our normal contribution methods, yep. We would
Yeah.
love to get more reports in that we didn't have to do ourselves, so yeah, definitely interested there.
Yeah, we think it'll definitely help increase community contributions that way too, because that'll give you guys a way to find reports, have them mapped, and get into us as well. So, great.
Thanks.
Yeah.
I think Sarah and Jackie have generously offered to do live demos for folks, not on stage, but folks in McLean, pull them aside. It's a pretty slick tool, and I'm pretty excited to hopefully open source that in the near future. So if there are no other questions, catch them during break, during the reception tonight, because they've done some great work here. Please join me in thanking Sarah and Jackie.